This is my third video lecture, and in this video I'm going to talk about integral calculus. So in this video I will tell about basic formulas and principle of integration, and then I'll solve few questions of very basic and easy level of integration. Okay, so let's get started. Integral calculus. Okay, so first of all, when we differentiate a function f of x, what we get is f dash of x. Okay, this we all know, and when we integrate it we get back f of x. So we can say that integration is the reverse process of differentiation. Okay, so if we know differentiation, we know halfway of integration as well. It's just the reverse process. When we differentiate a function, we get the derivative of it, and when we integrate it back, we get the function itself. So this is the relation between differential and integral calculus. Now, the basic formulas of integration are, first of all, x to the power n dx. So this is equal to x to the power n plus 1 divided by n plus 1 plus c. Okay. Now you must be wondering why this plus c. Always we put this plus c in this kind of integral equations. This plus c is because here we do not have the upper and the lower limits of an integration. Okay, so this is not a definite integral. For example, some integrals where we have this 0 to 1 or any other limit, or say a to b, when we have these limits we put the values here and this constant gets removed. But here, since we do not have the upper and lower limits, that's why we put a plus c. This represents a constant that we don't know since their limits are not mentioned. So in this kind of integral we always put a plus c to denote there is some constant here. Okay, next formula, dx. Okay, this dx means 1 into dx, right? So what is the integration of 1? Okay, what is the integration of 1? So let's see, we can use this formula. How? We can simply write this as x to the power 0 dx, because x to the power 0 is 1. Now here n is 0, so it will be x to the power 0 plus 1 divided by 0 plus 1 plus c. So this is nothing but x to the power 1, that is x, by 1, that means x, plus c. So the integration of dx is x plus c. Okay, so this value is equal to x. When we integrate 1, we get x. And remember, when we differentiate x, we get 1. So this is the reverse rule, right? Next, the third rule is exponential e to the power x dx. This is very easy. Exponential on differentiation and integration gives back exponential itself. But suppose when there is some constant here in front of x, what do we get? E to the power ax itself, as it was here, divided by that constant plus c, right? Next rule is dx by x. So this is log of x plus c. Okay, next rule, a to the power x dx. So for this, it is a to the power x divided by log a plus c. Okay, so we have covered the basic formulas. That is very much relevant and it will be sufficient for solving few basic questions. So let's go to the question. So our first question, integral root x dx. This is a very easy question, and here we just need to remember the formula rule. First rule, So this can be written as x to the power half dx, right? I told you that xn dx, when we integrate, we get x to the power n plus 1 by n plus 1 plus c. So here, when we compare it, n is half, right? So we will get x half plus 1 by half plus 1 plus c, right? So this is x to the power 3 by 2, 3 by 2 plus c. So this is the answer. This very easy and very fundamental question. Next question is 1 by root x dx. This is also very easy, but instead here of plus half, this is minus half. That's it. So n is minus half and it becomes x to the power minus half plus 1 by minus half plus 1 plus c. So this is x, right? 1 minus half, half. Here it is. So this is 2 root x plus c. This is my answer to the second question. Let's go to the third question. This is 3 to the power x dx. Okay, this is very simple question. Directly we'll use the formula. So it becomes 3 to the power x by log 3. Because here we'll use a to the power x dx formula, and that is a to the power x by log a, right? Plus c. A here is 3 and yeah, plus c would be there. So this is the answer for my third question. Next question. This is somewhat not very difficult, but yeah, it is comparatively difficult. Let's try to solve this question. So this is x squared by x plus 1 dx, right? Here we have to use some trick. What can we do is, let's put minus 1 and plus 1 in the numerator and see what can we do. Okay, now we can see x square minus 1 is there. We can use a square minus b square formula here. So we split it like this. Okay, plus we have 1 remaining. Okay, now we know a square minus b square, it's a plus b into a minus b. So a plus b gets cancelled. Only x minus 1 is remaining for the first part. And for second part, it is 1 by x plus 1 dx. Now it is very simple, right? This is x dx minus 1 into dx plus 1 by x plus 1, right? This is x square by 2. This is x. This is log, right? Plus c. So this is my answer. Okay. So this was somewhat difficult. Let's try to do somewhat more difficult question. Here, question is x cube plus 5x square minus 3 by x plus 2 dx. Okay, so we can see this is a cubic equation, right? So here trick is, somehow I have to get rid of this x plus 2, otherwise it's difficult to solve this integral. Okay, now x plus 2 tells me that minus 2 is a factor of this equation. So if I can get minus 2 factor in the numerator, I can cancel it out. So let's see what happens if I put minus 2 here. Okay, so if I put minus 2 here, it's minus 2 to the power 3 plus 5 into minus 2 to the power 2 minus 3. If I solve, it becomes minus 8 plus 20 minus 3, and that is 20 minus 11, and that is 9, right? So I'm remaining with 9. So what I can do is x cube plus 5x square minus 3. Let me add, I need 9, right? Because 9 is remaining here. So what I do is I add and subtract a 9 here, divided by x plus 2 dx. Okay, now I have x cube plus 5x square minus 12 plus 9 divided by x plus 2, x plus 2. So I have separated it in two parts. Now let me put minus 2 in this equation. I get minus 8 plus 20 minus 12. It becomes 0. That means minus 2 is a factor of this part, right? So I can write it as x plus 2 times something, okay, divided by x plus 2 dx plus this part 9 by x plus 2 dx. Okay, now this part is very easily solvable. It is 9 log x plus 2. But what about this part? I need to find this, right? Whatever is remaining here. Let's do it. So what I need to do is I need to divide x plus 2, this thing. I need to divide this x cube plus 5x square minus 12 by this, so that I can find out the remaining thing which is left over here. Okay. So first of all, x square, because x cube is there. So x cube plus 2x square. This becomes 3x square minus 12. I need a plus 3x. 3x square plus 6x. I need a minus 6 here, and that's it. Okay. So I got this divisor. The divisor is x plus 2. I got the quotient. So it is x plus 2 times x square plus 3x minus 6. Numerator is, and this is denominator. Okay. Now I can easily cancel this, and now it looks very simple. I just split it element by element, right? Okay. Now we already know this is what? X square. So this will be x cubed by 3. This will be 3x squared by 2. This will be 6x. This will be 9 log x plus 2 plus a constant c. So this is my final answer for this question. Okay. This was also very easy. We just need to use one trick here, that I need to split it in such a way such that x plus 2 gets cancelled. Okay. So in this way, we have finished few questions on the basic level of integral calculus. In the next lecture, I will talk about different methods and how to solve and how to tackle different questions of different levels and which trick to use. Okay. Thank you so much. That's all for this lecture, and I hope you like this video. If you like, please do subscribe and share it. Thank you so much.